Ladies and gentlemen, welcome to the 2016 EGU award ceremony. It is our great pleasure to honor our medalists and awardees. Ladies and gentlemen, please welcome on stage the president of the EGU, Hans Thybo.
Thank you, and welcome to this year's celebration of the awardees of the EGU. It's a real privilege to stand here to award this year's award winners, who are all among the best scientists in their disciplines. We are here to celebrate excellence in the sciences, and we are here to celebrate some of the finest minds in the world. And even though EGU stands for the European Geosciences Union, I'm very proud to state that, and we can see from the list of awardees, that our awards are given internationally without looking at affiliations or other regional aspects. So in this respect, I think the EGU is the most globally oriented geosciences organization in the world, and we are very proud of this. The awardees are all truly worth celebrating for their profound results, and thank you all for joining us tonight to celebrate these bright minds. Thank you.
Ladies and gentlemen, welcome on stage the Vice President of the EGU, Jonathan Bamba.
Hi. Well, I'd like to echo the words that Hans said. We're very proud of all of you. We're proud of our awardees and medalists, past and present. And we hope that you too are proud in some way of the organization that have awarded this honor to you. And we hope that as a consequence, when you leave here, you'll go out as ambassadors, both for your subject, but also for EGU. And that in doing that, you'll promote your discipline, you'll promote excellence in your discipline, but you'll also remember us and promote the organization to young and aspiring scientists and give them the same kind of ideals and inspiration and ideas that have made you such fantastic scientists. So thank you for being here, and we'll get the show underway.
We are now starting with the first group of awardees. Please welcome here on stage the 2015 Outstanding Student Poster awardees. Please applaud for Atmospheric Sciences, Jillian Young. Ivy Tan. Lukas Pfitzenmeier. Pierre Nabar. Thea Schiebel. For Biogeosciences, Adam Moreno. Gesheri Abdesa Gourmesa. Jonathan Ritson. Norman Rüggen. For Climate of the Past, Present and Future, Andrea Miebach. Inge Justzak. Christoph van Tricht. Michel van der Deus. Sönke Dangendorf. Sorab Vijay, Cryospheric Sciences. Mateusz Wuschnik, Earth and Space Science Informatics. Alexandra Kushner, Earth Magnetism and Rock Physics. Christopher Otto, Energy, Resources and the Environment. Venera Espaon, Geochemistry, Mineralogy, Petrology and Volcanology. For Geodesy, Christoph Barmann. Wolfgang Schwillus. For Geodynamics, Adam Holt. Moritz Medmann. Caroline Messenzähl, Geomorphology. Panos Georgiou, Geosciences Instrumentation and Data Systems. For Hydrological Sciences, Christoph Ritschel. Janek Dreibrot. Michael Stölzle. For Natural Hazards, Chiara Arrighi. Maria de la Fuente. Perrine Fredier. John Ariara, Nonlinear Processes and Geosciences. For Ocean Science, Annalena Deppenmeier. Benedikt Ehart. Yao Fu. For Planetary and Solar System Sciences, Daniel Fee. Jamie Molaro. Rachel Moore. For Seismology, Angélie Portal. Elizabeth Antwistle. For Soil System Sciences, Alfonso Pizarro. Michael Blaschek. Sarah Bitty. Suzanne Lutfalet. For Solar Terrestrial Sciences, Anastasia Tessari. Christa van der Meeren. Denise Dudkin. Tim van Peer, Stratigraphy, Sedimentology and Paleontology. And Hans-Jürgen Köll, Tectonics and Structural Geology. Ladies and gentlemen, please welcome here on stage the 2016 Division Outstanding Young Scientists. Please applaud Joseph Zettler, Atmospheric Sciences, Federico Baltar, Biogeosciences, Malte Stücker, Climate, Past, Present and Future, Peter Lippert, Earth Magnetism and Rock Physics, Ali Mohammadi, Energy, Resources and the Environment, Witold Rom, Geodesy, Pierre Vallard, Geomorphology, Jackie Kendrick, Geochemistry, Mineralogy, Petrology and Volcanology, Animesh Kumar Gain, Natural Hazards, Eric van Seville, Ocean Sciences, Xiong Huan, Planetary and Solar System Sciences, Joseph Deutsch, Seismology. David de Vleeshout, Stratigraphy, Sedimentology and Paleontology. Agatha Novara, Soil System Sciences. And Orke Falreng, Tectonics and Structural Geology. I am now calling the 2016 Division Medalists on stage. Please applaud Jason Morgan, Augustus Love Medal. Roel Snyder, Beno Gutenberg Medal. Karl Schreiber, Christian Huygens Medal. Sushil Atreya, David Bates Medal. John Husnans, Fridtjof Nansen Medal. Stephen Fusele, Hannes Alphen Medal. Paul Majewski, Hans Oeschger Medal. Joram Rubin, Henri Dassy Medal. Helen Glaves, Ian McHarg Medal. Lucas Lawrence, Jean-Baptiste Lamarck Medal. Harry Verreken, John Dalton Medal. Jeffrey Forbes, Julius Bartels Medal. Peter Reed, Louis Fry Richardson Medal. Thierry Fichet, Louis Agassiz Medal. Philip Meredith, Louis Neil Medal. James Sakos, Milutin Milankovic Medal. Agris Kalitis, Petros Peregrinus Medal. Heike Knecker, Philippe Dichuffaut Medal. Benjamin Horton, Plinius Medal. Neil Zovius, Ralf Alga Bagnold Medal. Tetsuo Irifune, Robert Wilhelm Bunsen Medal. Iracema Alcantara Ayala, Sergei Seloviev Medal. René Heilbronner, Stefan Müller Medal. Srinivas Bhattapur, Wenning Meines Medal. Maria Kanakidu, Wilhelm Bjerknes Medal. And Carlos Duarte, Vladimir Ivanovich Vernadsky Medal. Ladies and gentlemen, we are now awarding the 2016 Arne Richter Awardees for Outstanding Young Scientists. This award is dedicated to Arne Richter, who sadly passed away last summer. The award recognizes his entire life of tireless dedication to geosciences in Europe. I'm calling the Arne Richter Awardees for Outstanding Young Scientists on stage together with their citationists. Please welcome Bert Wouters and citationist Jonathan Bamber, Christian Möstl and citationist Richard Harrison, Grace Shepard and citationist Karin Siegloff, Kaveh Madani and citationist Amir Agashugushak. Jonathan Bamber is kindly delivering the citation for Bert Wouters.
So, simply put, Bert Wouters is one of the most exceptional and outstanding young scientists working in the field of polar science today. In the 5 years from completing his PhD, he has been an author on 38 ISI-listed papers, 8 as lead author, and including 6 in Science, Nature, and Nature Geoscience. His first results paper from his PhD, published in 2008, has now had well over 120 citations, and sets a benchmark for the analysis and interpretation of GRACE data, that's the Gravity and Recovery Climate Mission. For someone at his career stage, this is an exceptional track record. What is also exceptional about Bert is the breadth of his output, both within and across disciplines. His background is in satellite geodesy, but to attempt to pigeonhole him in a single discipline would be to play down his interests and his contribution to science. He's made significant contributions to ice sheet research, glacier and ice cap mass balance studies, but also across a range of related problems in Earth system science. Earth observation is his main area of excellence, but he's published on ocean modeling, global circulation model simulations, and climate prediction, and his breadth is rare in someone at this career stage. Wouters possesses the profile of an extremely successful, imaginative, productive, talented, and broad scientist who has a very bright future. I should also like to say that he's a former Marie Curie Fellow, and it's really fantastic to see these fellowships supporting the very best young scientists in Europe. So I hope you all agree he is a deserved recipient of the Arne Richter Award for Outstanding Young Scientists. Thank you.
Bert Wouters is presented the 2016 Arne Richter Outstanding Young Scientist Award.
Okay, John, thank you very much for these very kind words. I'm impressed by myself, I must say. I'm just going to repeat a little anecdote I told this morning at my talk. 10 years ago, I started my PhD, and whenever I would read about someone in his mid-30s receiving an early scientist career award, I would shake my head and wonder how anyone in his right mind could consider such an old guy to be an early scientist. Today, I'm standing here on stage, 35 years old, and I'm very happy that EGU is so relaxed about their age limitations. Thank you for that, EGU. But seriously, I think EGU does a great job in supporting early scientists, and I'm sure our next president will continue these efforts. Thank you.
Richard Harrison is kindly delivering the citation for Christian Möstl.
It is a great pleasure for me to deliver the citation for the Arne Richter Award for Dr. Christian Möstl of the Space Research Institute of the Austrian Academy of Sciences and Institute of Physics at the University of Graz in Austria. And I read from the citation. In his short career so far, Christian has made outstanding contributions to the subject of coronal mass ejections, their 3D structure and global shape, their propagation in the inner heliosphere, their effects at Earth, and their mutual interactions during periods of enhanced solar activity. This multifaceted research entails the analysis and interpretation of solar, coronal, heliospheric, and near-planetary observations, acquired both remotely and as well as in situ. The in situ measurements themselves often include data returned from various spacecraft widely spread out through the inner heliosphere. This synergy of data has given us a much broader view of how these major harbingers of disturbances in the terrestrial environment develop from Sun to Earth. Complementary to this, Christian has produced key research aimed at real-time predictions of solar weather at Earth. His initiative and wide grasp of many aspects of solar and interplanetary physics has led him to introduce a number of innovative analysis techniques and to extend the scope of old ones, which have greatly enriched the subject. His work has opened new vistas with far-reaching implications for our efforts to unite solar phenomena with their interplanetary manifestations and planetary impacts. During his work, he's established collaborations with leading scientists at space research centers all over the world. Aside from producing an enviable research record, Christian is deeply committed to sharing his knowledge with a wider audience. Thus, he's very active in organizing sessions at international conferences, but also in giving talks on the subject to the general public. In summary, Christian is not only one of the leading exponents of European geophysics in the world, but also one that's conscious of the duties of scientists to the general welfare. So, as I say, it is a pleasure for me to deliver the citation for Dr. Christian Möstl. Thank you.
Christian Möstl is presented the 2016 Arne Richter Award for Outstanding Young Scientists.
So thanks for the EGU for giving me this award. It's really very flattering. So first I want to thank the guy sitting there, Richard Harrison, who has built an instrument that's called the Heliosphere Imager on stereo, which was able to image for the first time the solar wind between the Sun and the Earth, which is as fascinating and challenging as it sounds. So thank you very much for making this possible. We live now in the age of scientific collaboration. I've encountered over the years so many great and smart collaborators, it would be impossible to name them all in just a few minutes I have, or just the 1 minute I have. So you know who you are. Maybe some of you are already here. Then I want to thank Janet Luhmann, I don't know if she's here, for hosting me at the University of California in Berkeley, where I went with a Marie Curie grant. I also want to thank the European Union for funding actually some of my research. And at the very last, but not least, I want to thank all the positive reviewers of my papers and grants, but just the positive ones. I don't know you, but you know who you are. Thank you.
Karin Siegloch is kindly delivering the citation for Grace Shepard.
Dear colleagues, Grace Shepard, PhD in 2014 from the University of Sydney and now working at the University of Oslo excels at studying the most mobile elements of plate tectonics and the mantle forces that drive them. Hers is a holistic approach that seamlessly integrates plate reconstructions, the tectonic record of continents and oceans, mantle structure as imaged by seismic tomography, mantle geochemistry, and geodynamic convection modeling in a quantitative and technically rigorous manner. Dr. Shepard's 13 published papers, 8 of them first authored in Nature Geoscience, Earth Science Reviews, EPSL, JGR, and other leading journals, have explored horizontal plate motions on a global scale, as well as vertical motions and dynamic topography, in groundbreaking and provocative case studies on continental scales. Her current focus on the subduction history of the circumarctic, an area of extreme terrain mobility over time, presents a most challenging setting, but one with a clear promise of breakthrough, thanks to major international data acquisition campaigns recently launched. Dr. Shepard is ideally positioned to be making these breakthroughs, thanks to her scholarly depth, cross-disciplinary scope, and comprehensive preparation. Shepard et al. 2013 was the first review to synthesize a new tectonic model of the Arctic that includes a thorough assessment of mantle structure and its links to surface observations. This work has become an instant reference. The geodynamic model of mantle-driven vertical tectonics in the circumarctic was pioneered by Shepard et al. 2014. Cited 479 times in just 2 years after graduation, Grace Shepard is destined for a career that will measure up well against prior recipients of the EGU's Outstanding Young Scientist Awards. Let's congratulate Grace Shepard for this great achievement.
Grace Shepard is awarded with the 2016 Arne Richter Award for Outstanding Young Scientists.
Well, thank you very much to EGU and the committee for this. I'm very grateful to be amongst the awardees this year. And as echoed before, I think it's a wonderful initiative for early career researchers. I'd like to thank Karin for her kind words, and also to Karin and Carmen Geiner for their nomination in this respect. My continued thanks go to Carmen and to Trond Torsvik for the wonderful and collaborative group that they've established at SEED at the University of Oslo. I'd like to also thank my PhD supervisor, Dietmar Muller, and the Earthbite group in Sydney, as well as collaborations I was very fortunate to have with, amongst others, Hans-Peter Bunger in Munich and Mike Gurnis in Caltech. And finally, I'd like to thank my parents who've even come from Australia. So thank you very much.
Armi Agakushak is kindly delivering the citation for Kaveh Madani.
It's a great honor for me to introduce Dr. Kaveh Madani, an exceptionally high-achieving early career scientist and one of the 4 recipients of this year's Arne Richter Award. Kaveh is recognized for his high-impact fundamental contributions to integrating game theory and decision analysis into conventional water resources management research. I have had the privilege of knowing Kaveh and collaborating with him for a few years now. He is a multidimensional person who is hard to keep up with, a rising star with an outstanding record in research, education, mentorship, and service. And I can go on by adding to this list his impressive frequent flyer miles and high cholesterol level, which is pretty much as high as his citations. Many of his publications focus on sustainability science and policy. Yet, he flies so much. Kaveh's carbon footprint is probably higher than many of us all together. I did some back-of-the-envelope calculations yesterday. Considering only his flight mileage, I have estimated Kave's carbon footprint to be around 15 tons of CO2 per year. So basically, he puts 200 times of his own weight, CO2 in the atmosphere, to advance the science of sustainability. Isn't that great? Thanks, Kave, for all the sacrifice you're making to make the world a more sustainable place for all of us. But I was wondering why he travels so much all around the world. I just couldn't understand it. So after all these years, I finally realized why he was traveling so much. In one of his science trips, not too long ago, he met his lovely fiancée, Soha, who is sitting back there. And now that the search is finally over and he has found the love of his life, I hope he starts working on cutting back on travel and reducing his CO2 footprint. Yeah, and this would be a major breakthrough, in my opinion, in bridging the gap between theoretical sustainability research and actual practice. But seriously, in the past couple of years, Kave's publications have received more than 400 citations per year. He has more than 50 journal publications, many more conference papers. Some of them are highly cited, hundreds of times. This clearly shows his impact in the field of water resources management and beyond. He is also a hydro celebrity. Kave is frequently invited to comment on water resources and environmental management issues in TV, radio programs, and in print media. BBC, REL, VOA, the New York Times, Financial Times, The Guardian, Newsweek, these are just few examples. He is highly respected in the field, thankfully not for his carbon footprint, not yet, but for his research and strong leadership in community building activities and for serving as a promoter of initiatives that bridge the gap between academic theory and practice. For all these reasons and many more, I am happy for Kave for this well-deserved recognition. Congratulations, Kave.
Kave Madani is presented the 2016 Arne Richter Outstanding Young Scientist Award.
So I think if there's a chance to pull back the award, I think EGU would do that with this citation. So lots of thank yous. I want to start with thanking EGU for giving an award to early career scientists. I think it's very encouraging. In the meantime, it comes with a lot of responsibility. Hydrologic Sciences for trusting the work of a non-traditional hydrologist or water resource engineer who still has a hard time publishing in water resource journals because of talking too much about humans. Amir Orakuchak for leading the nomination, is kind, supportive, very generous and humble. It definitely deserves this award more than I do. Surush Surushian, Pete Laux, Greg Charaklis, Bjorn Klov, Andrea Castelletti, Cynthia Uvo, and Ronnie Bankston for endorsing the nomination. My students, thank you guys for your hard work and great work, and sorry for being a jerk and asking for too much from you and asking you for more. My mentors and advisors, Keith Heipel, who got me into game theory, Jay Lund for encouraging me to do more work on game theory so I have my own signature area, and Ariel Dinar for helping me being a better communicator when talking to people of other disciplines. And I should also thank water itself for giving me great parents. My parents dated and met and got married working for the water sector, and the reason I'm working on the human side of water sector and conflict resolution is that we're getting a lot of frequent fights over water issues at home. especially my mom. I think I should thank her here. She studied with me word by word till the 8th grade, and she was always told that her son cannot survive a day after he leaves the house, being the only child and spoiled, of course. Thank you, Mom, for not giving up on me, and I wish EGU had an award for parents. And last but not least, my beautiful wife-to-be, who I did, met not long ago, but she has definitely impacted my life. I'm now much slower on responding emails and finishing reviews, and can't travel so much. So I'm cutting carbon emissions because I got a life. So looking forward to starting my journey with you this summer.
Group picture. Ladies and gentlemen, we are now presenting the 2016 Union Medals. Please welcome here on stage Jean Poussin and citationist Artemi Cerda, Don Burroughs and citationist Maria Kanakidou, Trond Torsvik and citationist Conal McNeokel, and Michel Mayor and citationist Özgür Karatekin. Artemi Cerda is kindly delivering the citation for Jean Poussin.
I got to take this opportunity to thank Jan for all he did for science. I remember that in 1990, when I arrived to Amsterdam to do part of my PhD, I sent a letter to Jan asking for one of his papers. And he replied me very fast. After 3 days later, I had the paper. Then I read the paper and I asked for 2 more. And then after 1 month, I had probably all his papers published. They still are in my office. He changed my life as a scientist. He gave me a target to be done in my life as a scientist. And why I proposed Jan as a von Humboldt medal is because I found during the last 20 years many scientists in our discipline that are doing good science because of the influence of Jan. Also during the last month, I heard from many colleagues that Jan was an inspiring scientist for them, was moving the science in the right direction, which is what I found also. Then it's well known. Also, this medal, I think, is based on his work for novel developed countries. With all the work that he has done in Africa is helping a lot the people from these countries, and I think he is deserving also for that. And finally, not only in general the physical geographers, also all the environmentalists around the world are in depth with you and with your science. But especially I want to mention that the Spanish scientists are changing a lot the view because of your influence. And my last word will be for about one topic that probably is not the most important for you now, but was very important for some of us when we started doing science, is that you show us that rock fragments are a key question in the science. You change it with your research about rock fragments, the impact on hydrology, on soil science, on geomorphology. You teach us how to approach a new topic. And we are applying this for many others. Then, Jan, many thanks for what you have done for the scientific world.
Jean Pusen is presented the 2016 Alexander von Humboldt Medal.
Well, dear Mr. President, Vice President, highly distinguished colleagues, ladies and gentlemen, today is a very special day for me, as you can imagine. Being awarded with the Alexander von Humboldt Medal of the European Geosciences Union for my research, particularly in the Global South, and this in the spirit of Alexander von Humboldt. No need to say that I feel very honored, and this for several reasons. I just give two of them. As you might know, Alexander von Humboldt was among the first scientists that moved away from a collection of encyclopedic facts and tried to start making links, looking at the geography of the issues. And because of his groundbreaking observations, he is being considered to be the, I would say, the founder of the scientific geography, and more particularly the founder of the scientific physical geography. Now, being a medalist named after Alexander von Humboldt, I feel extremely proud to get a medal with the name of such a famous geographer. But the other reason why I'm very happy with this medal is that, as you know, Alexander von Humboldt did most of his groundbreaking research in the tropics, in South and Central America. And I myself, I was born in the tropics, and from my childhood in the East African highlands, I keep fantastic, I would say, romantic memories. Tremendous, beautiful landscapes, a tremendous biodiversity, friendly people that lived in harmony with their environment. But today, as you know, the tropics are under threat. Rapid population growth, climate change make that there are very strong human-environment interactions that have devastating consequences. And receiving the Alexander von Humboldt Medal from such a large scientific organization like the EGU means for me that EGU highly values research also done in the Global South. This makes me very happy. Last but not least, I would like to thank many people, actually too many to mention, President Hans Thibault, Vice President, but also Professor Tammo Steenhuis, who was the chair of the Alexander von Humboldt Committee, then the many researchers under the guidance of Artemis Serda, who proposed me as a medalist. So, last but not least, many thanks go to the many colleagues, both in the North and particularly in the Global South, for many stimulating discussions that were eye-openers for fruitful joint research projects. I very much enjoyed collaborating with them, and I still hope to continue collaboration with all of you in the near future. Thank you very much.
Maria Kanakidou is kindly delivering the citation for Don Burroughs.
It's a great pleasure for me to introduce Professor Don Burrows, who has been supported for his nomination by an international group of scientists for his outstanding pioneering excellence in science that revolutionized research on the Earth's atmosphere, and for his numerous services to the international scientific community. Professor Burrows is Professor of Physics of the Ocean and Atmosphere at the University of Bremen, where he founded the nowadays outstanding for his Scientific Excellence Institute of Environmental Physics. He has a strong physical chemistry kinetic background, educated at Cambridge University in UK, and postdoctoral experience at the Harvard Center for Astrophysics. He developed, adopted, and used techniques that are applied physics like laser magnetic resonance, UV and IR absorption spectroscopy, and laser-induced fluorescence. He made a series of outstanding contributions to the understanding of chemical processes in the Earth's atmosphere. Professor Burrows started his scientific career in the 70s with several pioneering laboratory studies of the kinetics and spectroscopy of atmospheric constituents. He was one of the first to recognize the relevance of nitrate radical in removing nitrogen oxides from the atmosphere, and his studies of reactions of halogen species like CLO radicals. He was ahead of his time. These reactions were later found to be the key processes in the destruction of stratospheric ozone. Professor Don Burroughs paved the way of a satellite instrument in Europe, effort initiated by a single institution, which is an amazing task and pioneering work. He was the scientific leader of a small group conceiving and proposing Skiamaki and his miniature GOM, the first European satellite sensors for tropospheric chemistry studies, and the first satellite instrument to record full spectra in the UV-Vis range capable of globally mapping a large set of trace gases relevant for atmospheric chemistry. For his achievement in conceiving the ideas, designing the instruments, making it operational, retrieving data, providing many interpretations. Professor Don Burroughs is internationally recognized as the father of these first European satellite sensors and a new type of space-borne instrument that monitored tropospheric composition from space. They have been sent into space first by ESA and later by NASA and several other space agencies. The influence of these new satellite measurements can hardly be overestimated. These data led to a revolution in atmospheric modeling and gave a strong push to our understanding of atmospheric chemistry in the Earth system. Professor Burrows has been influencing and leading the European area in remote sensing of the atmosphere. He is a leader for European science in everything that he does. He has a great vision of things that are needed, ability to conceive others of his vision, and yet work with them as partners. His outstanding accomplishments are recognized by a large number of awards, prizes, and numerous positions in important international organizations. Overall, Professor Burrows has had an amazing, successful career as an atmospheric chemist. He started with laboratory measurements, slowly expanded to do field studies, and then skyrocketed into remote sensing. Because of his many groundbreaking scientific contributions to geosciences, his dedication in developing science and human capital, and his long history in community services, Professor Don Burrows, we believe, that fully deserves the Alfred Wegener Medal and honorary membership of the EGU.
John Burroughs is presented the 2016 Alfred Wegener Medal and honorary membership.
It's very surprising to hear about yourself like that, but I can only say it's a very great pleasure and a remarkable honor to be here. I would first of all like to thank, obviously, my nominator and my promoters, in particular Maria Kanakidou, and the EGU, the president, the vice president, and of course the prize committee, who actually awarded me this prize. This has been a long journey. It's gone very quickly. I'd like to thank my supervisor in Cambridge, Brian Thrush and Paul Davis, and Richard Wayne in Oxford, who were great people to get me going. At the beginning of my career, I enjoyed my time as a postdoc at Harvard Smithsonian Center for Astrophysics. I then had the good fortune to work in Oxford and at the Atomic Energy Research Establishment, and also at the Physical Chemistry Laboratory, all the time working initially as a kineticist and spectroscopist. By good fortune, I was then invited by Paul Crutzen to work in his new department at the Max Planck Institute at the time, in the beginning of the 1980s, or early in the 1980s, and that turned out to be a very important thing for me in a number of different ways. I was fortunate to be able to work in a very exciting environment with very good people, and in particular, Paul Crutzen, Dieter Perner, who says he's no longer with us, who together with Ulrich Platt invented this differential optical absorption spectroscopy technique, which we've exploited as a group from space. That was a very fortunate and very exciting time. I also thank, of course, Geert Mortgat for his teaching me more about spectroscopy. There are many people along the way. I would like to thank, of course, the German Aerospace, DLR, European Space Agency. There are many fathers of success, so to make satellites work, this is a hard business and very rigorous. Scientists have to learn how to be engineers, and engineers have to learn how to work with scientists. It's quite a challenge, but it's necessary, and I'll come back to that in a minute. But I'd like to go further and finally, and not, or in this sense not finally, but to thank the University of Bremen for providing me the opportunity and to become a professor and to build up a department there. This was a very important step. In particular there, I'd like to thank Klaus Kunze, who's a close colleague, and my newer colleagues. In this context, my close collaborators in Bremen have been a source of tremendous joy for me, and we've had the great fortune to be able to work on these projects and develop new ones. In terms of thanks, I have to thank my family, both my parents, my brothers and sister, and my wife and our son and the family. Coming to Germany meant that I also met my wife, so I'm some way down a journey now. My young colleague has just started one, or about to, but I'm some way down a journey in this respect. But this has been, the support of family is unbelievably important for scientists. It keeps you sane and keeps you on track. So I can't thank my family, in particular my wife, enough. With respect to the work, I think the driver, and I was early very fortunate to be involved in issues related to a big important atmospheric problem, which turns out to be one of the key anthropogenic influences on this new geological epoch, the Anthropocene. And together with my colleagues around the world, locally and around the world, we've been able to provide a lot of very interesting evidence-based data for the science, curiosity-driven science, which is what we do, but also to begin to provide the beginnings of an observational system which is required, hopefully, to manage the future where we're going to have 10 billion or more people. So we need to be able to do that, and the atmosphere is the early warning, so you need to measure that very well. So it's my great pleasure to be here, and I accept this award on behalf of the remote sensing and spectroscopic and kinetic community, and I hope that gives an impulse to Europe moving forward, in particular in measurements of things like CO2 and methane. Thank you very much indeed.
Colonel McNeokill is kindly delivering the citation for Trond Torsvik.
This next medal is named after the British geologist Arthur Holmes, of whom the great Canadian geologist Reginald Daly said that Arthur Holmes was the only English geologist of his generation who had ideas on a grand scale. And the same can certainly be said of this year's recipient of the Arthur Holmes Medal, Trond Torsvik. Now, some of you know Trond is Norwegian, and the Norwegians have an expression, alt eller ingenting, which means all or nothing. And those of you who know Trond will realize that he has lived up to this maximum in several aspects of his life, not least in a career where he's tried to understand the workings of the Earth from the crust to the core. I should also say that there's something of an irony in presenting him with a medal named after someone who was an early proponent of continental drift, because Trond was lured into the geosciences by a professor in Bergen with the specific goal of disproving plate tectonics. And out of deference to the occasion, I won't name the said professor, but what I would say is a testament to Trond's scientific acuity and a strength of character that by the end of his PhD, he had succeeded in disproving his erstwhile supervisor. Trond's early career was in paleomagnetism, and he was instrumental in deciphering the tectonic history of two Paleozoic continents, his own home continent of Baltica and the smaller continent of Avalonia. He memorably christened the conjoined tectonic entity after their Ordovician collision, Ballonia. And his vision extended to global plate tectonic reconstructions, where he is now the leading authority on pre-Mesozoic plate reconstructions. When Trond was starting out, it was very difficult to make plate reconstructions because there was almost no software available to do any of this work. And so, in addition to collecting the basic data, Trond also started to program plate reconstruction software on a PC that his father had bought for him. And this is software that he has made freely available to the entire community over the past 3 or so decades, and I speak of the GMAP software. He was also one of the drivers behind the G-Plates project, which is making open source plate reconstruction software freely available on the web. And Trond's career has also been characterized by his notable generosity, not only with software and data, but there are several generations of scientists who have ended up having to spend time on Trond's sofa in his house, as well as in his lab, being educated not only about science, but on the philosophy of science. The final strand of Trond's work that was mentioned by his citationist was his realization that the initial eruption sites of large igneous provinces line up with the edges of large, low shear wave velocity provinces in the lower mantle. And in a series of rather provocative papers over the last decade and a half, Trond has shown how these also explain the distribution of diamond-bearing kimberlite pipes and offer us the tantalizing possibility of linking surface plate motions to deep mantle dynamics. This is an endeavor that Arthur Holmes would surely have supported and an awardee that he would surely have approved of. And so it gives me great pleasure to present to you the winner of this year's Arthur Holmes Medal, Trond Torsvik.
Trond Torsvik is presented the Arthur Holmes Medal and honorary membership.
Well, thank you, Connell, for those dear words. I would have to say Connell was one of the first in the early 90s serious PhD students I had a pleasure of working with and hopefully educating. Presidents, ladies and gentlemen, I'm very honored to receive this prize, and particularly Arthur Holmes is one of my favorite scientists for many reasons. For those who doesn't know him, you know, he almost single-handed brought the age of the Earth from about Kelvin's 20 million years into 1.7 billion, almost overnight, in a book on the age of the Earth when he was 22, 23 years old. Also be aware that he was the second one ever to date rocks with the uranium-lead method, and the rocks he dated was from Norway, where I come from, southern Norway. His first paper published in 1911, where he got an age of 370 million years. But of course, he was there at the right time. This was shortly after the discovery of radioactivity, so it opened up whole range of new arenas for dating the Earth. Also in the 1940s, very important, he also was the first one to postulate there actually could be convection in the mantle, so that then turned out to be a potential driver for continents. So he was the very first one to propose that. I thanked a lot of people in my lecture yesterday, but I mention a few, particularly those who nominated me, which is Mike Gurness, which I worked with in America in 1993-94, Rob Vanderwoo, Wim Spakman, who is here, Dietmar Miller, Taras Geria, and John Broadholz. Of the more old-timers, I have a reputation of only working with very, very old people, so unfortunately many of them have left us. One of the survivors at age 87 is Kevin Burke, who inspired me a lot, but we always had endless debates and discussions. Also want to thank Robin Cox. He's a little younger, only 78, still alive, and perhaps the one I published the most with. And he's a paleontologist. He's an expert on brachiopods. And we always had a wonderful relationship because I always trust his interpretation of his brachiopods, and he always trusts me when I do my plate reconstruction, so we hardly ever have an argument. Those who were very close to me in my early career, I would like to mention, I started off originally in mathematics, then I wanted to do physics, but I wasn't good enough. So I saw this word in the catalog called geophysics, so I thought I'd try that. I started first out in oceanography, believe it or not, but then I actually switched to magnetism. I thought that was the field. And the one who really taught me everything, that was really laboratory work. It was Radar Lovely, who passed away a few years ago. And then I also got interested in geology, and that became one of my best friends in my life, Brian Sturt, who passed away a long time ago. But the most important, Brian Sturt, was maybe not the geology, but he taught me how to get grants. How do you win money? Because you need a certain amount of talent, whether you're young or old, but you need money, so you have to figure out how to be effective. So for the money, I really think the Norwegian Research Council will be very generous, the European Research Council, and and finally, a great thanks to EGU and the President.
Özgür Karatekin is kindly delivering the citation for Michel Mayor.
It's a great pleasure for me to give the citation for Michel. Michel Mayor, Emeritus Professor at the Astronomical Observatory of the University of Geneva, is a major figure of modern astrophysics. The research of Mayor and his team has had a unique and major impact in the fields of exoplanets. The detection in 1995 of 51 PEG-B, the first extrasolar planet orbiting a solar-type star by Mayor and Didier Queloz, initiated a fantastic and rapidly developing new domain of modern astrophysics, reactualizing fundamental questions about our origins and the place of humankind in the universe. Today, several thousands of exoplanets are known. Mayer's contribution to the field has been far more profound than the single detection of the first exoplanet. He has been continuously working on the improvement and the diversification of detection methods for exoplanets on their characterization. In particular, he led the development of HARPS, High Accuracy Radial Velocity Planet Searcher, spectrograph for the European Southern Observatory, which is today, 12 years after installation, still the most precise instrument in the world for the measurement of the masses of rocky planets. Very early on, he also contributed to the measurement of the radio of exoplanets, giving access, together with masses, to the planet mean densities, a bridge towards geosciences. Mayor is also an active contributor in the research and extrapolation planned by current space missions by organizations such as NASA in the Kepler telescope, or ESA, CORO, the convection, rotation, and planetary transit missions. He has been the leading figure in the development of a new domain of astrophysics, interdisciplinary in nature and opening to adjacent fields as geophysics, climatology, mineralogy, and astrobiology. For all these reasons, he is a worthy recipient of the EGU Jean-Dominique Cassini Medal 2016.
Michel Mayor is presented the 2016 Jean-Dominique Cassini Medal.
We have the privilege today to be at the beginning of the comparative exoplanetary science. Fascinating domain revealed by the observed diversity of exoplanetary systems, ocean planets, super-Earths, inflated gaseous giant planets, and many more. Combined data from Doppler spectroscopy and planetary transit allow the estimation of the bulk density of thousands of planets, fossil traces from their formation. Transit spectroscopy opened the way to also analyze the composition of planetary atmosphere. Astrophysics and geophysics have a new common domain of research, revealing the complexity of planetary formation, an exciting domain supported by half a dozen of space missions, and already large, big telescope on the ground. I'm extremely honored from having been chosen to receive the Jean-Dominique Cassini Medal. Thank you.
Ladies and gentlemen, the president of the EGU, Hans Thybo, is kindly closing the ceremony. Thank you very much.
Ladies and gentlemen, we have been honoring excellence in the sciences tonight. The citations that we have heard in the division meetings for the division medalists, and we have heard here tonight for the Arne Richter awardees and the union medalists, really demonstrate a huge breadth and the high quality of the geosciences as is being carried out. It also demonstrates the importance of our geosciences to society, I believe. Our science is about observations. We are collecting data, we are processing data, we are interpreting it, and we are coming up with sometimes very sophisticated models. But in reality, science all rotates around people. Without people and interaction between people, we cannot do science. And this is the reason that the EDU is giving these awards to honor those people who are being role models for how we can carry out our science. We also hope that you are indeed all role models, definitely. And we all, in EDU, we also hope that you will, for the future, also be ambassadors for the geosciences and also for the role of the EDU that we can play in the development of our sciences. And with these words, I would like to say thank you to everyone for coming here for honoring our awardees. And I would like to invite you for a reception outside of here, where we will once again have a chance to celebrate our awardees. They will unfortunately probably disappear pretty soon because there will be a bus waiting for them. But there will be a chance to have a small chat with them and for the rest of the week. So thank you everyone for coming, and once again congratulations to our awardees. Thank you.